I think knowledge is power. And when we give good people, which is you guys, good information, they make better decisions, which will hopefully will lead to better homes and better customer satisfaction. So what we want to do today is dive into what the stress of our homes look like during transportation to see if there's ideas that we can glean to improve the effectiveness of our homes during transportation to reduce transportation related service issues and damage. So let's dive in. All right, let's look at specifically ceiling damage during transportation and look at how the stresses of the home and the axle placements and some of the way we construct our home may be contributing to ceiling board damage. We're going to look at, in this example, we're going to look at a epic house, epic failure. We're going to look at how the home transportation forces work and are distributed throughout the house. I really think that's the big takeaway here. We're going to look at how the spread axles or adding more axles actually may be contributing to the problem, making it worse. And then we're going to look at reviewing the ceiling tension cords and splices and how those play an important role. We'll look at reviewing possible other items to eliminate the issue, including limiting the axles and spacing, positioning them properly to balance the stresses in the home, improve those tension members, those strong backs, how they're fastened into the truss and the splices, and look at reinforcing the chassis beam, as well as placing the roof edge rail over the top plate when possible. All right, this is the house. As you can notice, it's in the yard. It's already starting to lose the camber in the rear end. There's 6 axles and there's a space between the two sets of 3 axles there. So when you look at the chassis print, it looks like this. And I see this quite a bit with manufacturers or facilities. They think by adding axles or spreading them out, it will reduce the stress because the spans become less. So that's why I wanted to put this short presentation together to show what's actually happening as far as the building science and the stresses. But one of the contributors to this, when we space the axles out in this manner, we're assuming that they all carry equal amount of load and it's all uniform and that they're all carrying load. While in reality, the house goes across bumps and railroad tracks. And so if you notice in this video, when the first axle goes across this tracks, the rear axles are completely off the ground. See them sitting there completely off the ground. So all that load is actually going to the front axle. The stress in the box is the highest at that point. So let's look at the house. Here it is. Those front axles are placed about 39 feet from the hitch, where the rear axles are placed about 62.5 feet from the hitch. So they're spread out pretty far. But when we design the engineering, we're assuming that all that load's going at the center of the axles, which is at 50 feet. So let's look at what our assumption is in engineering, what the stresses would be versus what happens when we spread them out and we go over a bump. So this is the green axle arrow in the front represents the load at the hitch. I turned this blue line represents our house at a profile looking at from the side. That rear to the left green arrow represents the load that the axles would be carrying. That's how we design it in engineering. So when we do that, what we're looking at here are engineering stress analysis. That middle is a shear diagram. All it does is it shows the shear, the length of the house. Notice how the shear is the highest right here at the axle area, and then it gets higher again at the hitch area in the front. Same way with the moment. And I've drawn the moment upside down. As Purdue engineers, that's how we do it. That's how we were taught because it reflects the deflection of the structural member closer. So in the axle area here, you notice a high negative moment. And then in between the axle and the hitch, there's a positive moment. So the way we designed it at 50 feet, centers of the axles, the load at those axles would be about just less than 26,000 pounds. The moment would be 152,000 feet-pounds, that's feet-pounds, and then the positive would be 74,000 feet-pounds. All right, let's look at when we place the axles towards the rear. When we do that, the load substantially goes down at the axles. So the farther you move your axles to the rear, the less load the axles are actually carrying, the more hitch load it's carrying. What does that do to the moment? Well, that negative moment where we're seeing the tension really high in the ceiling and it cracks goes down. And the positive moment actually goes up, but it's still less than 200,000. Let's look at what the stress does when we look at all the load on the front axle. When we look at all the load on the front axle, the axles carry almost all the load. So this example, the total load of the house, we're assuming it's 34,000 pounds, right? 33,000 of it is going to the axles when we place it at 39 feet. So as soon as that house went over that railroad track and most of the load was going to that front axle, that axle is carrying an awful lot of the weight. There was very little, if any, load on that hitch at that point. And so that's the shear. So when we're looking at shear, that's when your walls would crack at that location, in that location at 39 feet back from the hitch. That front hitch, if you're seeing wall cracks in that location, that's what's going on. That's what's contributing to that. But look at the moment though. The moment at that negative moment in that 39 feet location goes to 300,000 feet-pounds, which is double what it was designed to carry, which is a problem. So roughly the ceiling tension is going to be about negative moment divided by 10, because it's the distance between the ceiling centroid of the tension member and the chassis, which is carrying the other component. So if you think about our homes going down the road, it's like an I-beam, and the ceiling is the top flange, which carries the tension. The floor and the frame carries the compression of the bottom flange, and then our walls carry the shear in between, which would be the web. If you think about an I-beam, where can you put holes in an I-beam? Well, it's the web, because the web's really carrying very little load other than shear. And so when we look at this, we divide the load by 10, that would give us the tension in the roof. And if you notice, at 50 feet, it was designed for about 15,000 pounds tension in the ceiling. But when that goes over the railroad track and that front axle is at 39 feet, that tension in the ceiling goes to 30,000 pounds. And that's why it breaks. It's not designed to carry that. It won't carry that. As a secondary point to this, we want to try to avoid placing doors and window openings or strengthen those openings in that location over the chassis. And that's why the shear is the highest in that location, especially in those front axles. If you put your axles to the front, that shear gets even higher, as we've shown here. So keep that in mind when you're designing a house or when you're building a house in those locations. If you have a door or window, those are the ones you really want to pay attention to strengthen those members. It put OSB reinforcement. That would be the place to get your most bang for your buck if you in those areas. So this is what a tension members failure looks like. You have a horizontal crack in your ceiling, and it will oftentimes follow recessed lighting, because those are penetrations in the tension member, and so it's going to fail there because there's less member. Looks like this. If you see these are telltale signs of a ceiling tension failure. That's the first thing to recognize. That means you're putting too much stress in your ceiling gypsum, okay? And those repairs can be pretty expensive. You gotta go up there. Sometimes we actually see those strong backs break or pull away because of the tension that they're carrying. And so you get up there and you replace ceilings and you level it out. This one was originally in the yard. If they just make the ceiling repairs and then pull it down the road, they'll have to repair it again, would be my prediction on site, because the same thing will happen. Carrying the tension, and won't be able to carry it in your rear of your house, that rear end past the rear axle will have a tendency to sag, fall apart. So what can we do? There's two parts of the equation. One is to reduce the stress, which would be moving the axles back and properly positioning the number of axles to get them closer to that 50 feet design location. And the other one is to strengthen your tension members. So let's look at strengthening our tension members. Tension members are your longitudinal roof members, particularly the strong backs, as we're looking at here. So in this particular case, they're using a 2x3 strong back, which is really strong. It's good for about 3,100 pounds of tension, which is great. But if you look at the splice connections, they have about 8 15-gauge staples, which is good for about 300, less than 400 pounds. So they're not getting their money's worth on the tension member. But what they could do is put a lot more fasteners. We're talking 30 fasteners would be better on each side of that splice rather than 8. Or even better, put glue, full glue coverage on both sides of those splices could get you about 3,000 pounds of tension in that same member. So putting a little bit more effort in those splices will get you a lot better results and fewer ceiling cracks. It will also result in fewer wall cracks, as we looked at it in the stress, because you're carrying the stress and the tension members where they're designed to carry them better. But you also have to fasten those strong backs to the truss properly. So pay attention to that. Again, if you're putting 2 fasteners in, put 4 from the strong back to each truss. You'll get much better results. The other thing that we see is where the top plate and the edge rail are. If we can place the edge rail, as this picture on the left shows, directly over the top plate, it distributes the stress from the walls to that ceiling tension member much better. And that edge rail is actually carrying the tension as well. But when you have the fascia as the only member out there, like we see on the right, that what we're finding out is that stress does not transfer through the trusses into that fascia member very well. In fact, the only way it can transfer is through the truss to top plate connection, and you're limited by that one nail or whatever. And what happens, especially at opening areas, is you get a concentrated load in your gypsum's going to crack at door and window corners. If you've seen that, putting a continuous edge rail above the top plate would substantially help that for that reason. So if you can avoid the empty bay over the top plate in between trusses like that, even if it's a OSB strip that's, again, spliced properly and properly connected to your trusses, it would help quite a bit. All right, so let's recap here and wrap this thing up. Talk about the ways we strengthen our home for transportation. First, by reviewing and improving the roof strongbacks, their connection to the trusses and the splices of the strongbacks. Look at the sidewall and mating wall roof rails as part of those tension members. At your mating wall, make sure that you have either a glue block or a number of straps from your ridge beam to the rail so that you have a continuous tension member along your mating wall as well. That will help. If you can place the roof edge rail directly over the top plate, as we showed, you'll get better results. That will make it a stronger box and be able to carry that tension even better. And then really look at your axle placements. You may be putting more axles than you need because of where they're located or spread out. Contact us and we'll help look at your home, your model, your specific stress points to optimize the placement of those axles. And then if you're still experiencing some problems, consider reinforcing in the I-beam area, either by a sister beam or a flat bar in that tire and axle area. By doing those things and understanding these stresses of the box as it goes down the road, I think we can go a long way of working together to reduce stress in the boxes or our homes during transportation, which will result in less door problems, less drywall cracks, less ceiling cracks, less tire and axle problems as we really think through this. And we are looking into other ways that we can strengthen our boxes during transportation. We have a UT intern working with us to run BIM analysis of what we're talking about here today, where we can actually model where we put strength, put money, and to make sure we get the most bang for our buck in this process. So thank you for your time. If you have any questions or comments, please let me know. We're here to serve you and to help you. Let's work together to improve customer service and make better homes. Thanks. Have a great day.